Now, so far what we have done, we have studied separately. If body is at rest, so we have plotted position time graph, or when body is moving, we have plotted velocity time graph. We have studied it separately. Now what I will do, I will take one state of body. Suppose body is at rest. Now, for this state of body, we have to plot position time graph, velocity time graph, acceleration time graph. Similarly, if I take the state of body as body is moving with constant velocity, then we have to plot again position time graph and velocity time graph, again acceleration time graph. If I say the body is moving with a constant retardation, then we have to plot all three, means position time graph, velocity time graph and acceleration time graph. Okay, so for a given state of body, how we can plot the different graphs, that we will see today. So first I will take position time graph, means it is nothing but we can call it as ST graph, and velocity time graph I will take it as VT, and acceleration time graph for body at rest, for object at rest or body at rest. Okay, for an object at rest. Okay, so this is ST means what? Position time, velocity time and acceleration time graph. Okay, first I will draw the ST graph, that is position time graph, ST graph when body is at rest. Okay, so I will take along the y-axis, what I have to take? I have to take position. Yes, I will take along this axis, and as usual time you have to take along the x-axis. S means what? S means position. T means what? Time. Okay. So what they are saying? They are saying the body is at rest. Body is at rest means it may be at say suppose this is the reference point. Body may be at here. It may be at 10 meter distance from the reference point, or it may be at 20 meter from the reference point. That is not given. So you may take 20 equals to 0. Body may be here. Okay. So it is at rest means what? The position will not change. Position will not change with time. After 1 hour again it is at 10 meter. After 2 hours again it is at 10 meter. That means the position remains constant. So this will not going to change. So graph, what you will get? You will get a graph, a line parallel to x-axis. When t is 1 second, here only, and t is 2 second, position is same. When t is some 4 second, position is same. That means this distance is not going to change. Okay. So maybe you can take some 10 meter or something. I have taken it as S1 also. Okay. So similarly, for the same body, if I draw velocity time graph. So here what will happen? We have to take velocity along the y-axis, time along the x-axis. Okay. See here, when body is at rest means it is not moving. When body is not moving, velocity is going to be what? Velocity is going to be 0. If velocity is 0, suppose here 10, 20, 30 like that, and here 0 is there. So when t is 1 second, it is 0 only. When t is 2 seconds, velocity is 0 only. When t is 3 seconds, velocity is 0 only. That means velocity is not there only, because body is not moving only. So that is why graph you will not get somewhere here, because this is what velocity is. If you come here, it will become 10. If you come here, it will become 30. It is having 0 means it is going to be coincide with your x-axis. This is what the graph. So v equals to what? P equals to 0. Okay. Now, if I plot the graph of acceleration time graph, so what will happen? You have to take acceleration along y-axis, and time along x-axis. So this is the time, this is the acceleration. So if v is 0, means what? Acceleration is also 0, because acceleration is what? V by t, rate of change of velocity. So that is why. So when t is 0, acceleration is 0, when t is 1, acceleration is 0, when t is 100, then also acceleration is 0. So again you will get graph on the x-axis. So this is what going to be your graph. So acceleration is also what? Acceleration is also 0. Okay. So these are the graph of position time, velocity time, and acceleration time graph for what? For the body at rest, or when the object is at rest. Okay. Now all three graphs for an object. For an object moving with constant velocity. Okay. So now we will plot the graph for an object or body moving with constant velocity. Okay. So first one is what? Position time graph. Okay. So you have to plot the graph in such a way that its velocity should be constant. Its velocity should not going to change. Okay. So take position along y-axis, time along the x-axis. Okay. If you want to get the constant velocity, what is required? It should travel equal distance in equal interval of time. Okay. So what will happen when for 1 second it will travel some 10 meter. Again for 1 second it will travel for 10 meter. Again for 1 second it will travel for 10 meter. Okay. 10 by 1, 10 by 1, 10 by 1. What you will get? You will get the constant velocity. So this is what the graph. Graph of what? Position time. When time is 1 second. So what will happen? If this is going to be say some 10. So when time is 2 seconds, so this is going to be say some 20. Okay. So here also it has traveled 10 meter. Here also it has traveled 10 meter. Again next it will travel 10 meter. So it is traveling equal distance in equal interval of time. This is what? Position time graph for object moving with constant velocity. If you want to check, you can take slope over here. So 20 minus 10 divided by 2 minus 1. So 20 minus 10 by 2 minus 1. What you will get? You will get it as 10 meter per second. Here if you take this slope, 10 divided by 1, again you will get 10. If you take slope over here, you will get 10. Again if you get slope here, you will get 10. So slope is what? Slope is constant. Slope is constant. And we know that slope of position time graph. Remember from previous classes, slope of position time graph give you what? Velocity. So velocity is going to be constant. Okay. So this is what the graph of position time when object is moving with say some constant velocity. Okay. So this is what the graph you have to show for constant velocity. Okay. So now if I graph velocity time, if I take a graph of velocity time, velocity I am taking here and time I am taking along the x-axis. Okay. So everywhere what we are getting constant velocities. Means we are getting some 10 value. Velocity is 10 meter per second. For next time, velocity is 10 meter per second. So velocity is not going to change. If suppose this is the 10, this is going to be a constant for first second, second second, third second, fourth second. Velocity is not changing. So v is constant because here we have taken what? V only. Here we have taken position, that is why it is changing. Now velocity is not changing, that is why we are plotting graph for object moving with constant velocity. So this is what we will get the constant. What about acceleration? Acceleration time graph. Little have to concentrate here. Acceleration we are taking along y, time we are taking along x. Okay. Now if velocity is constant, suppose here also it is 10, here also it is 10. So what will happen? This is 2, time you can take 2 and 3. What will happen? Acceleration is what? Change in velocity divided by change in time. So acceleration is final velocity minus initial velocity. 10 minus 10 divided by 3 minus 2. So what will it? You will get 0. When velocity is constant, when velocity is not changing only, you are moving with some constant velocity. You are moving with some constant velocity means you are not accelerating, so your acceleration is 0. You simply have some value and you are just sitting on the vehicle. Okay, so acceleration is going to be what? Acceleration is going to be 0. So your graph is coinciding with what? Coinciding with your time axis, means it is coinciding with your x axis. Okay, so this is what acceleration is equals to 0. Okay, so these are the what? Position time, velocity time and acceleration time graph for an object moving with constant velocity. Okay. Okay. Next, position time, velocity time, and acceleration time graph for an object moving with constant. We can take, say, acceleration. Constant acceleration. Okay. So if body is moving or object is moving with constant acceleration, then how we can plot position time, velocity time, and acceleration time? Okay. So now first position time graph. Okay, so position time, so time and position. Yes, I will take here. Okay, remember, if you want constant acceleration, velocity should change with some constant values. Okay, every time velocity increase by 10, then what will happen? Acceleration will be constant. To change velocity, so your displacement or your distance should change with some values, not constant, with increasing values. Okay, so position should be with increasing value, with increasing value. Position, I will write it as, yes, it should change with time with increasing value. Okay, it should the position should increase with time. Okay, so suppose if I plot the graph like this. Okay, now the slope will give what? Slope of position time graph will give you what? Velocity. Okay, so now if you calculate slope over here, this, so it is small, so if you take slope over here, so your numerator is what? Increasing. If you take slope over here, again it is increasing. If you take slope over here, again it is increasing. Okay, so this numerator is increasing. This is what? Delta S or delta X, delta X, whatever you can say. This is what? Delta T. So your velocity is what? Delta S or delta X by delta T. So if numerator go on increasing, if numerator is increasing, that means what? Velocity is increasing. Velocity is increasing, but increasing with some constant values that we will see. So if I plot the graph of velocity time for this one, velocity time for this one, time I am taking here and velocity I am taking over here. Okay. Now maybe if you consider this slope as 10, this should be what? If you look at the values, it is looking like double. Okay, so it may be 20. It is looking like triple, so it may be 30. It is looking like 4, so it may be some 40. So it is what? Displacement is changing or changing with some values. So that is why your velocity is also increasing with some standard value. So that is why you will get this slope like this. So if it is here 20, here it is 30. So 20 minus some 10. So here it is, if 20 minus some 10 will give what? 10. 30 minus 10 will give what? 10. 40 minus 10 will give what? 10. So your velocity is going to be what? Your velocity is increasing with constant value. Increasing with constant value. Okay. So that is why you will get the slope over here. This is what the graph. Okay. If you calculate the slope of this graph, so what will happen? So you take slope over here, or you take slope over here. If you take slope over here, anywhere you can take the slope. Slope is going to be what? Slope is going to be constant. Slope is going to be constant. So what is the slope of VT graph? Slope of VT graph will give you what? Will give you velocity. Will give you the velocity. Okay. So what will happen if it give you the not velocity, it will give the acceleration. Okay. So slope of VT graph gives you what? Acceleration. So acceleration is going to be what? Acceleration is going to be constant. What we wanted that only. Object moving with constant acceleration. So obviously this graph is giving you what? This graph is giving you some constant acceleration, So for that, position time graph should be like this. Velocity time graph should be like this. So what about acceleration time graph? So acceleration time graph. So time is along x-axis, acceleration along y-axis. So already we got acceleration is what? Constant. So it may be some 10, 20, whatever. So that is going to be a constant. So A is what? A is some constant. So line parallel to time axis or x-axis. Okay. So these are the what? These are the graph of acceleration graph for an object when it is moving with constant acceleration. It is moving with some constant acceleration. Remember all three graphs. Very important. So now next we'll plot the all three graphs for an object moving with say some constant retardation. Okay. So we'll say retardation. Retardation means or deceleration. It is velocity is decreasing. Okay. So now if velocity is decreasing means if I want to plot the graph of position time. So time you take along x, position you take along y. So position should change in such a way that velocity should decrease. If I plot the graph like this, so what will happen? If you take a slope over here, more. If you take a slope over here, it is less. If you take slope over here, it is less. If you take slope over here, it is less. If you take slope over here, it is less. This is less. Okay. So what is happening? Time to constant. This go on decreasing. This value go on decreasing. Means delta S is decreasing. What is V? V is delta S divided by delta T. Delta T is the constant. Don't worry about that one. Delta S is what? Delta S is decreasing. Okay. If this is constant, so V is what? V is directly proportional to delta S. So if delta S is decreasing, that means what? V is also decreasing. V is also decreasing. Getting the point? So V is decreasing with time because slope of ST graph gives you what? Slope of ST graph gives you velocity. So if slope is decreasing means what? Velocity is decreasing. So this is what the graph of ST for constant retardation means velocity decreasing. So now, so here, so velocity I will take along y, time along x. Now, initial for first time, velocity is what? Maximum. Then velocity become less. Velocity decreasing, velocity decreasing, velocity decreasing, velocity decreasing. So what you will get? You will get the graph with a decreasing velocity. So what we can say? We can your graph will be like this. So what is this? This is what velocity is decreasing. Velocity is decreasing. Okay, but it is positive. It is not negative. The direction is not changing. Okay. Now if you take a slope, over here, slope will be what? Slope will be negative. One thing. One more thing is what? If you take slope over here also negative, but both the slopes are what? Both the slopes are going to be equal. So that means slope is what? Constant. So slope of VT graph give you what? Acceleration. But what you are getting? Negative acceleration. So A is equals to some constant but with negative sign. Okay. Negative sign indicates what? Negative indicates retardation or deceleration. Retardation or deceleration. And it is some constant. We are getting value as some constant. So this is very important while plotting the AT graph. What they are saying? Constant retardation. So we got both retardation and constant. Okay, because acceleration slope we are getting negative. If you plot the graph of acceleration time will be along here. So acceleration is constant. That is not a problem. You may get line or parallel to x-axis, but it is negative. So that is why you will not get above the time axis. You will get the graph below the time axis because negative values are here. So what will be the acceleration time graph? It is a line parallel to time axis or x axis, but below the time axis or below the x axis. So this is what is constant but with negative value. Okay. So this is what the graph for graph for the constant retardation. Okay. So what is happening? Here your displacement is go on decreasing. Here displacement is go on decreasing, and here velocity is decreasing. Okay. So these are the graph for an object moving with constant retardation. So next is what we are doing is for a given state we are plotting different graphs. All three graphs are plotted. We can get velocity from what? We can get velocity from position time graph. Okay, but acceleration from velocity time graph. Then you may ask, can we comment something on acceleration by looking at position time graph? Acceleration we are getting from what? We are getting from velocity time graph. Can we comment? Can we say something about acceleration by looking at position time graph? Yes, we'll see whether it is possible or not. So what we can say? Acceleration. Comment on acceleration from position time graph. Okay, or position time graph. Position time graph. Okay, so we'll see. Suppose you are having say this is what your position. Yes, I will take along y-axis, then t I will take along x-axis. Okay. So if it is accelerating, if it is positive acceleration, what we will get? We will get the graph like this. Okay. So here what is happening? If you take the slope, what you will get? You will get what? You will get velocity. So slope will give you what? Velocity. Slope of S3 graph will give you what? Velocity. Here velocity is what? Velocity is increasing. Velocity is increasing. So v is what? Increasing. V is increasing means what? Acceleration is positive. It means that acceleration is positive. Okay. From this graph, what we can understand? We can understand that the acceleration is going to be what? Positive. Acceleration is going to be positive. Similarly, if I plot position time graph here, yes, I will take y, so t I will take as x. So what will be? Graph will be like this. Okay. So here what will happen? Velocity go on decreasing. So velocity is what? Velocity is decreasing. Velocity is decreasing means it is coming from 50 to 40. So acceleration 40 minus 50 divided by 10. So what you will get? You will get acceleration as negative. Acceleration is negative means what? Acceleration negative means body is retarding. So by looking at ST graph also you can comment on the acceleration. Okay. So what we can get here is curve is what? Curve is upward. Here curve is what? Downward. Okay. So here curve is upward. Here curve is downward. Okay. So that is why if you refer your NCERT book, you will see two graphs. So what is that? They have drawn acceleration, position along here. They have taken s or x, whatever. So we are taking s, so take it as this. So time here, and one more graph is like this. So here it is time, and here it is position. Okay. So one graph you can see like this, and another graph you can see like this. Okay. So this is what? Graph is curved upward. So graph is curved upward. Graph is curved upward. Here graph is curved downward. Here graph is curved downward. Okay. So what we got here, when curve is upward, your acceleration is what? Acceleration is positive. So acceleration is positive, velocity increasing. Here, when curve is downward, acceleration is negative, so velocity is decreasing. Getting the point? That means here body is accelerating. Here body is accelerating. Here body is retarding. Okay. Remember these two graphs, very important. So from the position time graph, you can comment on the what? You can comment on the acceleration also. Okay. So remember, when curve is upward, positive acceleration, velocity increases. When curve is downward, so what will happen? Acceleration is negative and it is decreasing, and velocity is decreasing, and body is under retardation. Okay. So what we got in the position time graph? In the position time graph, if this is S and this is T and S. So if suppose curve is upward, so if a curve is upward and here what? Curve is downward. So if curve is upward, A is what? A is positive, means if body is accelerating, and we will what? We will increase. Here, if it is downward, A is what? A is negative. A is negative. That P is what? P is decreases. Okay. So here what? Body is accelerating. Here body is what? Retarding. Okay. So if suppose in position time graph, S and T, if it is like this, what will happen? Slope will become what? Slope will become constant. Slope will become constant. So V is constant, means A is what? 0. Okay. So if from the position time graph, if this is the case, A is 0. If curve is upward, A is positive. If curve is downward, A is negative. Moving with constant velocity, moving with increasing velocity, moving with decreasing velocity. Moving without accelerating, moving with positive acceleration, or it is accelerating, or it is decreasing, it is retarded. Okay. So if suppose you are having some random curve, suppose if I show you something like this, this is what? This is position time. Yes, I am taking here, and time I am taking on this axis. So this is what? Position time graph. Position time graph. Okay. Now what we have to do? We have to comment at a different parts. Okay. Suppose now if I look at here, so curve is what? Curve is upward. Curve is upward means A is what? A is positive. A is positive. Okay. So now if I take a tangent over here, if I take a slope is what? Slope is nothing but velocity. So velocity is what? Velocity is increasing here. Velocity is increasing. If I come to this point, so what? Here it is downward. Curve is downward. So A is what? A is negative. A is negative means what? It is retarding. So velocity what? Velocity decreases. Velocity decreasing. Okay. So if I take this slope over here at this point, so dx by dt or ds by dt, slope is going to be what? 0 here. That means velocity is going to be 0 at this point, but again it is decreasing. So again it is changing. Okay. Now if I take over here, it is a straight line. It is not a curve over here. It is a straight line. In the position time graph, it is a straight line. That means what? That means velocity is going to be what? Here V is constant, not 0. So velocity is going to be what? Velocity is going to be constant. That means acceleration is going to be 0 for this one. Okay. Again here it is what? It is upward. So A is positive. So V increases. But instead of that one, if you take this one, here again what? P is going to be 0 because slope is going to be 0. Okay. So like this, Whichever the curve is given to you, you should be able to what you should be able to identify what is happening in what time. Suppose if you take a part of curve from 3 to 4 seconds, so what is happening there, whether it is accelerating or retarding or constant velocity, you have to comment on all these things when you just look at the graphs. Okay, so little practice about the graphs, very important. So we'll see in the next class.